Here we have a ruthless 11 marker that will test your moment skill to the utmost degree. I mean, come on guys, I did 2 questions in the past week on pure. I can do 1 question on my face. This is quite tough. It has theorem elements alongside mathy ones. First off, why is the friction to the right? Why is it going that way? The simple reason for it is because you have forces going to the left from the tension of the cable, pushing the rod to the left. Well, that's going to start accelerating it if there's not something opposing it. And friction opposes acceleration. So if it starts to accelerate to the left, then friction will act to oppose it to the right. Simple enough. Next bit, show that T is 2mg cos theta. This one's just a matter of taking the moment, and because the cable is at 90 degrees, it makes life quite easy because you can just work out the components of the m and 2m normal to the rod. And those are the ones that are going to be in the same orientation as the cable. So if you take around moment, be very careful with the lengths. You take the normal components just by doing mg cos theta and 2mg cos theta. And you have the masses which are going to cause a clockwise motion. And then you have the cable which is going to cause a counterclockwise ones. Rearranging brings the correct answer as 2mg cos theta. Here things start to get a bit tricky for the third part. Work out the force exerted on ground at A. You have to figure out all the vertical forces exerted on the rod. 2 of them are obvious, the M and the 2M. What about the last one? It comes from the tension. So the tension is going to apply a horizontal force to the left and a vertical force upwards, which you work out by taking the cos of the tension. If you do that, it gives you 2mg cos squared theta, which is the only force acting upwards. Taking forces up is equal to forces down, and so for Fa gives you 57 divided by 57 mg divided by 25 as requested. Finally, 4 marks. Show that the coefficient of friction is 8 over 19. This one I would argue is probably the one that you do the least amount of work, but it requires a lot of understanding. If you pay the attention to the rest of the question, you'll realize that the horizontal force going to the left is going to be opposing the friction going to the right. Friction is mu times the reaction. Well, you already worked out the reaction at A in the previous part, so you just have to do mu times Ra, or Fa, is equal to the horizontal component, and the horizontal component of the tension is sine theta of t because of this triangle here. So if you do that, it's going to be 2mg cos theta sine theta. If you make them equal to one another, it's solved for the final answer as 8 mu being 8 over 19 as requested. Looks tough, but your boy makes it look